Welcome to Spaceverse, your portal to cosmic adventures. Have you ever looked up at the night sky and wondered, where did all of this come from? Sure, we've all heard about the Big Bang, cosmic inflation, and the idea that our universe is expanding. But what if everything we know, everything we've ever seen, felt, or measured is just inside something else? Something even stranger. Something dense, mysterious, and rotating. Something like a black hole. As wild as it sounds, the James Webb Space Telescope may have just uncovered a clue that could turn our understanding of the universe completely upside down, or more fittingly, inside out. Since it began observing in 2022, NASA's $10 billion James Webb Space Telescope has completely revolutionized the way we see the cosmos. Its ultra-powerful infrared eyes allow us to look deeper into space and farther back in time than any telescope before it. And while it's revealed countless distant galaxies, stars, and cosmic structures, its most recent discovery may be the most mind-blowing yet. Scientists working with the JWST Advanced Deep Extragalactic Survey, or JADES, have been studying a sample of 263 galaxies from the early universe. These galaxies are so distant that the light we see from them has traveled over 13 billion years just to reach us. That means we're seeing these galaxies as they were when the universe was still young, just a few 100 million years after the Big Bang. Now here's where things get strange. In a random, isotropic universe, you'd expect galaxies to spin equally in both directions. About half should spin clockwise, and half should spin counterclockwise. But that's not what JWST saw. Out of the 263 galaxies observed, a full two-thirds of them rotate clockwise. Only one-third spin counterclockwise. That's not a random distribution. That's a pattern. According to scientists, this pattern hints at something truly profound, the possibility that our universe has a preferred direction. A sort of cosmic spin. A built-in bias to the way matter is rotating on a universal scale. This led Dr. Lyra Shamir of the Carl R. Ice College of Engineering to propose two possibilities. One, that the universe was born with a spin, and two, that our current understanding of the cosmos might be missing something fundamental. As it turns out, there's one theory that fits surprisingly well: black hole cosmology, also known as Schwarzschild cosmology. The idea may sound like something straight out of science fiction, but it's based on real, peer-reviewed theoretical physics. First proposed by Raj Kumar Pathria and later explored by mathematician I.J. Good, the theory has gained renewed attention in recent years thanks to Polish physicist Nikodem Poplawski of the University of New Haven. Poplawski suggests something radical, that the universe we live in might actually be the interior of a black hole that exists inside a larger parent universe. It might sound crazy, but the math adds up. Here's how it works. When a massive star collapses at the end of its life, it can become a black hole, a region of space so dense and warped that not even light can escape its gravitational pull. Traditional general relativity says that everything falling into that black hole gets crushed into a singularity, an infinitely dense point where the known laws of physics break down. But Poplawski's version of the story is different. In a modified version of general relativity that includes a property called torsion, a kind of twist in the fabric of spacetime, the collapse doesn't lead to a singularity. Instead, as matter becomes more and more compressed, the torsion builds up, creating a repulsive gravitational force that halts the collapse before the singularity can form. Then, something incredible happens. The matter undergoes what Poplawski describes as a bounce. Like a spring being compressed and suddenly released, the ultra-dense matter rebounds and begins to rapidly expand. Sound familiar? That's essentially what the Big Bang is, a sudden, rapid expansion of matter and energy from a hot, dense state. Poplawski believes this bounce could be the Big Bang. So if his theory is correct, our universe didn't start from nothing. It started from the rebound of a black hole's core inside a larger universe. And every black hole in our universe might spawn its own baby universe the same way. Each black hole becomes a kind of cosmic seed, giving birth to a new universe behind its event horizon. From the outside, you'd see a black hole. But from the inside, a vast, expanding universe just like ours. That brings us back to the spin. Black holes, like the stars they come from, often rotate. They have angular momentum. So, if our universe was born inside a rotating black hole, it might have inherited that spin on a cosmic scale. And that spin would leave a mark. Poplovsky believes that the rotation of our parent black hole could have left a preferred axis in our universe, essentially a universal direction that could have influenced the rotation of galaxies billions of years later. That preferred direction could be exactly what JWST is picking up on when it observes more galaxies spinning clockwise than counterclockwise. According to Poplovsky, a preferred axis in our universe, inherited by the axis of rotation of its parent black hole, might have influenced the rotation dynamics of galaxies, creating the observed clockwise-counterclockwise asymmetry. This model not only explains the strange spin pattern, but it also provides elegant solutions to several long-standing cosmological puzzles. It helps explain why the universe appears so flat and homogeneous, even in areas that should be causally disconnected. It offers a new perspective on cosmic inflation and could shed light on why we observe large, mature galaxies in the early universe, galaxies that, by current models, shouldn't exist so soon after the Big Bang. But not everyone is convinced. There's a more conservative explanation, too. It's possible that the spin bias observed by JWST isn't cosmic at all, it might be local. Specifically, it could be caused by the rotation of our own galaxy, the Milky Way. While scientists used to believe that the Milky Way's rotation was too slow to influence deep space observations, it's now being reconsidered as a possible source of measurement bias. Dr. Shamir points out that if the Milky Way's rotation is skewing JWST's observations, then we may need to recalibrate how we measure deep space. And such a recalibration could have ripple effects throughout cosmology, changing how we measure distance, time, and even the age of galaxies. If that's the case, the spin imbalance may not be evidence of black hole cosmology after all. Still, if future observations continue to confirm that galaxies across the universe show a preferred direction of spin, it may become one of the first direct pieces of evidence that our universe was born inside a rotating black hole. It would be a revolutionary shift in our understanding of reality, suggesting that what we think of as the entire universe is just the inside of something else. And somewhere in some larger cosmos, that black hole still exists, its event horizon cloaking an entire universe spinning just beneath the surface. So what does this all mean? It means that the answers to our biggest questions, where did we come from, and what is the universe, may be hidden not in the vastness of space, but in the darkest depths of gravity. And it means that every time we look up at the stars, we might just be looking out, from inside. If you found this video as mind-expanding as we did, make sure to hit that like button and subscribe. We're just getting started exploring the universe's biggest mysteries. Until next time, this is Spaceverse. Keep looking up and maybe, just maybe, think a little deeper about where up really is.